Okay, I think we can start. Okay, uh, we have been live for about 3 minutes now, I guess. So people could could hear some of our chit chat. So let me just briefly introduce myself and uh, today's guest. My name is Mirza. I'm the head of AI at InnoBoost. And with me is Henrik Mader from IBM Germany, solution engineer working working on AI on power. So I see that we have some guests from from the Middle Earth. So New Zealanders, welcome. Thank you for joining, and also thank you for joining to everyone else. Um, I figured maybe just a brief bio because actually Henrik is one of the brilliant people I always wanted to have, a conversation with, and this is the format we went with. Um, just a brief, overview. So Technical University of Munich, top of the class, then then IBM, I guess internship, and then starting to work on some real heavy duty stuff. So I just wanted to ask, you know, just give us a brief overview of the path. How did you get to, working on AI on power and
Okay, yeah,
yeah.
yeah. I
So
think you
kind of
sold.
break the ice.
Yeah. I think you sold me better than I could ever do it. But yeah, in the end, so my journey to AI on power, as you said, was basically through an internship. So I basically studied like information systems, and I had like a specialization in data science, AI. Started with like simple operation research, optimization stuff, and then went more into like machine learning stuff in university, and then Gen AI at the end. And yeah, I before I started at IBM, to be honest, I did not know anything about power servers. So power servers were the first time, or like I touched a power server the first time that I started working on my internship, and then I thought that like this intersection of AI and infrastructure is like extremely appealing. I mean, there's a lot of music currently in that market, a lot of stuff going on, and yeah, I'm since my internship, I'm here working in the DACH region as like a solution engineer, doing like POCs. I'm talking with people from research, with development, but also work with sales and see what actually works in the market and what doesn't. But yeah, that's my journey basically.
Okay, that's actually quite cool. Uh, that you work at the intersection of both things, because that's the case for me as well. And also for me as well is the case is that I didn't know a lot about IBM, before I started working for InnoBoost, and the guys were, IBM business partners. So this is where I started, um, learning more about it. And I'm sure, I mean, I repeat this all the time. IBM does so many cool things, but it's just not loud enough. When Google does something, they're like, it's everywhere, Meta, Amazon. You just see it everywhere. You don't see this kind of effort, so to say, from IBM, and I think it's mostly because IBM is primarily a company of engineers. So when they do something, they're like, "Well, this is great," but it's engineers, like building for engineers actually, and then you have people who understand it straight away. Uh, but but it is, a bit more difficult to know some things about what IBM is doing, and among other things, Spire Card, which we should probably get into because we could probably, talk about different things for a long time. But let's get into Spire Card. So, um, since we don't know the actual knowledge level of all the people who are here, let's just have a brief intro on the Spire card. What is it? What is it used for? And then we will move on.
Okay, yeah, sounds good. So in the end, these Spire cards are basically a AI accelerator card, which can be attached via PCIe. So like just an external AI accelerator card. And the card in itself has like 32 AI accelerators, like cores basically. I mean, those are just some technical stuff, probably pretty interesting for the technical people, but it has like 128 gigabytes of memory. And in the end, like these Spire cards are put in a bunch of eight. So you're not putting one Spire card into your power or mainframe server, but you're always taking like eight memory. So that's just a different architectural thing inside of the Spire cards. But from a system overview, I guess the biggest difference is actually that you're using eight Spire cards instead of like one really powerful card that you're attaching via PCIe.
Okay, cool. In terms of the actual, because we talk a lot about Gen AI these days, and obviously you don't really, if you're a smaller company, even if you're a big enterprise, you're not going to be training a large language model, in your data center. Um, so the question really is inference versus training. Like, where does Spire stand in these regards?
Yeah, as you said, I think that's absolutely true, and I think to make that distinction, that's super important, right? Like to make the distinction between training models and really just using those models and doing inferencing with them. I mean, the thing is that, like for example, with small machine learning models, you could also train them, right, as a company. But we are talking about Gen AI and LLMs and so on. So these Spire cards are actually positioned as making the inference of LLMs efficient. And when I'm talking about efficient, I mean like cost efficient, energy efficient, and all of those. So the Spire cards are as you said, like training cards for large LLMs. They're really like efficient inference cards. And also, as you pointed out, like if you're a company, even if you're a large company and a big enterprise, then I'm not quite sure if you're doing a lot of training of LLMs. Maybe you do some fine tuning and you do some adaptation of an LLM for your context, but you will not train an LLM from scratch. No way. Like you have the big providers who are doing that. So yeah, the Spire cards are really positioning itself as being a energy efficient inference card. That's really the distinction here.
Okay. I think when we discussed previously, I think you had some stuff to share regarding the consumption and the effectiveness, because from what I remember, it was more uh, on the generation of token per second, but also it has something to do with power consumption. So I don't know if you want to go into that a little bit, because I think it's interesting from the cost perspective also.
Right. Are you referring to like the relationship of like tokens per seconds and the generation and memory bandwidth and all of these components in the system, right? Yeah. So that's maybe interesting for the people who are listening in and like who know some stuff about AI infrastructure. But like the big driver for performance of like AI systems and AI accelerators are mainly determined by two things. So the first thing is memory bandwidth. So memory bandwidth between the cores and the memory that you have in your AI accelerator card is extremely important, because your token generation speed, so like the speed when you're asking ChatGPT a question and you see the tokens coming out of that, that's really determined by how much memory bandwidth you have on a AI accelerator. And the other one is like the time to first token. It's also super important. So you ask a question and then like the first token comes out, and that's basically determined by how much compute, how much Terra operations per second your AI accelerator has. And then I guess the third component for let's say AI accelerators is basically how much memory you have on the AI accelerator. Like, is your model able to fit into the card and serve a large number of concurrent users? So these three things are basically determining a lot of the stuff that's going on. And I mean, then you can optimize for the things. You can say, I want a lot of memory because my use case basically makes a lot of sense here. You can say, I want to go full out on memory bandwidth, just from a architectural standpoint of AI accelerators. But these are really the three things which are determined, like how much performance you in the end get out of your AI accelerator. Yeah.
Yeah, that's quite interesting, and I think also from my perspective, people are looking at AI as, something like, give me a kilo of AI, please, and sometimes even in more technical, circles, you don't really get that level of understanding that AI is just the tip of the iceberg. Below it you have the data, you have the processes, and I mean, maybe one of the most important things also is that you need to have some kind of an infrastructure. So from my perspective, if you already have, power machines sitting somewhere in there, and you're putting them to good use, why not use them for AI workloads as well? That is, if you are focusing, of course, on inference, because we get it a lot. People are like, we want to do AI, okay, so you get into the infrastructure questions, and they're like, oh, so do we have to buy, GPUs, new servers, new storage, all of that stuff? But then a very, down to earth answer is, if you have something, why don't you start there, on a smaller scale even, and then we can look at how we can scale it up.
Absolutely. And I think you mentioned like one point, which is really the focus of the Spyre card. So the focus of the Spyre cards is to make it super easy for the Power ecosystem. So for our customers, for people who are actually using Power servers, for IT admins, to infuse AI into their workflows and into their daily lives. That's really like the key. We are not just saying this is the AI accelerator card and then we're stopping it, but we actually want to make it pretty easy. For example, one thing is that we are using VLLM basically, or like the Red Hat AI inference server, which is using VLLM under the hood, because it's just industry standard to use that for requesting answers from an LLM, to have like this OpenAI compatible endpoint. So we're using that, for example. But we're also like giving out software for different use cases, which we are seeing that the demand is just there. For example, I mean, this is kind of the marketing thing, right? This turnkey AI. But in the end, that's the idea, that we are saying we are not only providing the AI accelerator, but we're also providing out-of-the-box services and software. For example, a RAG pattern, which is like engineered by us, and which is just given to you, and you can like install it with a few clicks and a few command lines, and then you have a RAG out of the box basically, and can use the Spyre cards for that. And that's really like back to your point, what you said, making it easy for people who already have Power servers to use AI in their daily lives, or like to just start with AI. That's really the focus that we are also striving for.
Yeah, and then also this is to an extent where your data is anyways, so you don't have to think about moving it, or thinking about loading it somewhere else. It's just there, so it's at the point of processing more or less. So I mean, again, this is my perspective, and I might be biased because I'm working for an IBM business partner. But if you can start somewhere simple, I mean, that's always That's always the best thing. So this kind of brings us to a next question. Um, are specialized accelerators such as Spyre, are they better for enterprise AI workloads than having massive GPU clusters?
Yeah. So maybe a question back to you. So when you're talking about massive GPU clusters, like what's like your ballpark to
Yeah, it's like
get an idea?
it's like massive for me is like 100 GPUs or something like that.
Okay. Yeah. Yeah. So that's the thing. So 100 GPUs, like let's say NVIDIA H100, NVIDIA H200, that's a lot. It is absolutely, and it has a high price point. I mean,
For sure.
To buy the cards, you have like a lot of energy running on that, and so on. I mean, a GPU cluster could also be a way smaller cluster. For example, let's say 8 NVIDIA GPUs. So my point, why I'm asking that is that the people have like a perception that for training you need to have like these massive GPU clusters that you were mentioning, and that's absolutely true. Like training an LLM requires a lot of workload. But even when you're talking about inferencing is also no free lunch, to be honest. It also costs something. So, for example, when you're running a chatbot inside of your company and you want to run that completely on premise and you have a large model for that, then you also need a lot of hardware for that. So it's really no free lunch. So my answer to your question, right? Like, do specialized AI accelerators make more sense for enterprise AI workloads? I would say yes and no. It really depends. It always comes down to the use case, to the requirements that you have, to the model size, for example, that you have, to the number of concurrent users that you're having, and this really influences stuff. So, for example, let's say you're doing a RAG chatbot for your IT operations department, and for example, you want to assist them in an on-duty call, right? In an on-duty call, you have not a lot of recurrent users like who are doing that, because on your on-duty call, there are just not so many people there. So does a GPU cluster make sense for that, or like even 8 NVIDIA H100? No way. It would be just an overinvestment and an overkill. Let's say you want to roll out a chatbot for your whole company, and you're expecting to have like 3,000 or 5,000 concurrent users, like people who are actually working on this system concurrently, not people who can access the chatbot, but people who are actually working on the system concurrently. Then it gets more expensive, and then like a small GPU cluster makes sense. So it really comes down to the use case and where you're at.
Okay, interesting. That kind of, because I saw something recently around Claude Code, because I use it as well.
You should use Claude.
that was one of the things. But yeah, I saw that actually the cost of there's this max subscription of $200 per month for Claude Code. I've read somewhere, so like disclaimer, I don't know if it's true or not, their estimates, but they say that one such subscription might actually cost between $2,000 and $3,000 in compute. So basically, what Anthropic is doing, and all of these huge AI companies, they are subsidizing to an extent all of the things that we are doing now, in hopes that either compute becomes so cheap in the near future, or, and this is my bet, that we get models that are a bit smaller, that are a bit more efficient, and then the cost is not so big. And I think you know where I'm going, because one of the strategies of IBM, actually one of one of the bets, so to say, was to focus on small language models. So basically, you have the Granite series of models that has more or less everything that you might need in an enterprise. They have the embedding models, they have the guardrails, they have the visual models that also work with docking built in. Uh, what is your stance on this? What do you think? Do you think that we will just continue scaling, in infinitely, or are we going to turn to more specialized models that can actually run on any type of hardware?
Yeah, I think the 2 points that you're bringing out are absolutely valid, right? Like either, and I mean the example that you gave with Anthropic and Claude, and that they are subsidizing that a lot. I think that also makes a lot of sense for me. I could imagine that's absolutely true. So yeah, I think compute can become cheaper, and it will become cheaper. But I also think that a big leverage is as you said, like the LLMs, and focusing on having more specialized models, and also thinking more about like a whole workflow of like let's say you have a business process and you have like the whole workflow. Maybe you would get the biggest the biggest increase of your business process by having a model which is just extracting like entities out of a text, right? So you have a text, let's say an email, and you just want to extract some words out of that text, and that maybe has a huge leverage on your whole business process. So for that, you would not need like a huge model. You would not need like your 120 billion models or something like that. You could absolutely do it with a 7B model or something like that. And you're also seeing that when you're looking at these benchmarks, like these general purpose benchmarks, that the small models are actually catching up. They're not completely there where the large models are, but the tendency is just there. And you also see a diminishing return on the large models. So they do not have these huge jumps anymore that they had like 1 or 2 years ago. So my stance on it is, yeah, I think the biggest leverage is actually having better small models, and that would also like play absolutely in the cards of our Spyre cards, because we want to make inference more efficient. We want to make it enterprise ready, and we do not want to like kill everything with more performance, with more bandwidth and more scaling, but to have like the best hardware for these scenarios. And I also think like mixture of expert models are amazing for that. Yeah.
Okay, mixture of models, mixture of experts, sorry, models. Um, I don't know if I have some knowledge about it. I don't know if our listeners or viewers know something about that. So maybe we could spend a couple of minutes there just to explain the concept and what it is and why it's why SpireCard could be good for running these types of models.
Yeah. I mean, I will cover the infrastructure part. You can cover the what mixture of expert models are and so on.
Okay, so basically, mixture of expert models are models that are quite big, most of them. However, when you are inferencing, they're only using just one part of their node network. So basically, if you have a 70 billion MOE model, when you are doing inference, there is a router model that actually routes your query to the corresponding part of the network, and then you are using just that part of the network. So you might end up with inference of, the entire model might have 70 billion parameters, but once you get into the inference part, you might be using 10, 13, or something like that. So it actually increases the efficiency of the model, and it also reduces the infrastructure need, which is where we get into the Spire card.
Yeah, and I mean, Coming back to the thing that I said earlier, right? Like the three things which are determined, like how much performance you have in an AI accelerator and in infrastructure. Either you have a lot of memory bandwidth, or you have a lot of compute, or you have both, or you have a lot of memory. And that's really the thing, right? Like mixture of expert models, as you said, they're pretty huge. But during inference, just a small part of the network is actually used. So what would be good for a mixture of expert model? It would be good to have a lot of memory because the models are still huge, but you do not need to have, in relation to the memory, you do not need to have so much compute and not so much memory bandwidth. And I think that's really just shows that, like, depending on the workload that you have, and that's why this intersection for me of AI and infrastructure is super exciting, is that depending on the workload, if you're running a mixture of expert model, for example, you just have different requirements for your hardware. And for the Spyre cards, that's actually pretty good. Like, I mean, we have 128 gigabytes of memory per card, and we are putting like 8 cards into the power server or into the mainframe. And during inference, we are mostly using 4 cards. So we have 512 gigabytes of memory. That's a lot, right? So you could fit a huge model into that. But this huge memory also comes at the cost of having less memory bandwidth. But it doesn't really matter for a mixture of expert model because you still have enough performance to like power the smaller number of parameters, right? So yeah, mixture of expert models absolutely interesting for the Spyre cards. Yeah.
Okay, pretty cool. And what about GPUs? Do you think? I think you said once that you would, if you had the power to do so, maybe you would design GPUs differently. If you just had, mixture of expert models.
Yeah. Absolutely. So that's the thing. If we are sticking with the mixture of expert models on GPUs, you actually see a different relationship between how much memory the card has and how much memory bandwidth and tera operations per seconds you have. So on the Spyre card, you are here with your memory that you have on the card, and you're like, let's say, here with your memory bandwidth and your compute. And on NVIDIA cards, this is basically completely reversed, right? You have, for example, on, I don't know how much you have on the H100, H200, I think around 96 gigabytes of memory. But they're super powerful, right? Like a lot of compute, a lot of memory bandwidth, but not so much memory, right? So for a mixture of expert model, that's not really optimal because like you have the huge model, and then you're fitting that into the NVIDIA card, and then you're just using a tiny fraction of the compute and memory bandwidth that you actually have in the card. So that's really the trade-off, which is happening in AI infrastructure.
Exactly. Yeah. So it's basically an overkill. You're spending a lot of money, and you have the compute, but you're not using it to the full extent.
Absolutely, yeah. And I mean, not trashing on GPUs or anything like that here, right? Yeah. I think that does not make sense, but that's really the thing. Like, what workload do you have? What models are you using? Maybe you're also using like embedding models and you're using vector databases. Then that actually completely shifts like the requirements that you have for your hardware. Maybe you do not want to use a mixture of expert model, but you want to use let's say a Mistral model with 128 billion active parameters. And then that also shifts like the stuff that you need for your infrastructure. But I think that discussion needs to be a bit more at the center, and it should not always be, let's do GPUs and that's it, and that's the holy grail of AI infrastructure. But think about like what your use cases and what the hardware should look like, right?
Yeah, actually, I think that's one of the key points that you're making here, because this is actually what we see, not just with our customers and the people that I talk to. It's more or less everywhere that you are not really looking at the business case. As a company, you are not looking at the scale that you have and you need, but you are instead going for, give me the best thing, even though it costs a lot of money. And then in, 2-3 years, when you don't actually see the ROI, then you're like, oh, AI is a scam, it's too much hype. No, AI is really useful, but it's really useful if you implement it properly, if you implement it for the things that you actually need it for, right? Um,
Yeah. Yeah.
so so basically, uh, when we start the conversation, the conversation is always, what is the business case? How are we going to do this in the best possible way for you, to reduce the effect it has on the business, but to also maximize the impact, so to say. So you don't want to break the current infrastructure, and this is really where I would say IBM excels, because the ecosystem is quite strong, and you have more or less everything you need. Now, one of the things that we will actually have an opportunity to discuss in the next episode, just a small plug, and I hope that we have more people joining there as well. But one of the things that we will actually discuss is open source, and how IBM is using open source recently. So we've seen the Granite models that are completely open source, enterprise level models. On the other hand, you have things like Dockling, and I know that you're a big fan of Dockling, as well
Yeah.
as I am. Um, and then you have, Kuga, the agentic framework. I've seen another agentic, something agentic, also quite new. I can't remember what it is. Uh, what are your thoughts? I mean, okay, obviously the infrastructure can get quite expensive. You can use what you already have. But what about the platform? What about the software, that you're using? How is open source actually affecting what we are doing right now?
Yeah. So when we're talking about the software side of Spyre, then I mean, I said this earlier about the OpenAI compatible backend, right? Like, we try to just like follow what the market says, and use technologies which are basically industry standard, like VLLM, or like Red Hat inference server, and these API endpoints, which are well known by professionals. What we also using, and that maybe is interesting because you mentioned Dockling. I was saying that we are not only focusing on the AI accelerator and making that and having that for a good use case or something like that, but we are also giving out the software. And the first use case which we saw at a lot of customers was actually like RAG chatbots in the end for IT operations. And it's no wonder that we're seeing that, in my opinion, because the people that we're talking to a lot are people working with power servers and people who are working in the infrastructure department. So we want to make the life for them easier, and a chatbot with like a RAG pattern underneath the hood, where they can just like upload their documents, which contains maybe sensitive IP addresses and host names and all of that, is just makes a lot of sense. So that's why we first started with that one, but there are multiple more use cases now coming out. And yeah, that software, this RAG pattern, basically uses the components that you were mentioning. Like, it uses Dockling, it uses a vector database, it uses a React front end, and then it has like all of these engineering components in it, where people actually should not care too much about, especially when they're working in the infrastructure. Like, why should you care about what re-ranker you're using? Or like, why should you care about the embedding models or the chunk size and all of that, right? So that's the idea, that we're really like giving you out a whole fully engineered RAG solution, which has all of the nice components that you were mentioning, like docking and so on. Yeah.
Yeah, I think actually to kind of continue on what you said, I think one of the, well, it's not really a problem, but it is a challenge that I see a lot, is that having something relatively useful is quite easy. with AI.
Mm,
So when you are talking about the RAG use case, for example, having, building very simple RAG, it's quite simple. But having a RAG that actually makes an impact on how you get your information, that's quite difficult because, like you said, you have the choice of the embedding model. You have the hybrid search. You have the re-rankers. You have the infrastructure around it. So tuning all of these, variables takes a lot of time, and I actually saw in a couple of situations that companies started on their own,
mm,
building these RAG use cases, and then they were just stuck. We are stuck here. We don't know what to do. So, like it happens that they come then to us for some specialized help. Um, and in those regards, I think what IBM did there is quite good. That you have it, it's built in, it's self-serve. You just take it if you need it. And I know that you said it's for IT operations, but there are obviously, a lot of different use cases. I know that IBM uses it for HR,
mm.
that you have the internal tool for that. I know that there is one for Red Books, if I'm not mistaken, also where you can, get stuff that you need from the Red Books. Okay, that's a bit more technical, but my point here is that a lot of companies actually start with the internal knowledge system.
Mm.
Because it's quite easy to get started with it. It's not a super complex for the business. I mean, use case doesn't have this process breaking effect, and then the returns that you see are more or less immediate because you have easy access to the information that you couldn't have before. You save a lot of time, and this is actually really really good. Um,
Yeah,
one po- yeah.
maybe to extend on that, as you said, yeah, like in the end, it's a fully engineered RAG pattern, right? So nothing holds anybody back if they're saying, as you just described, like why not have a RAG chatbot for our line of business? And why should they not be able to like access that chatbot and upload their own documents and just like search through them, right? Absolutely. It's not just IT operations, but with this RAG pattern, and that's the beauty of it, you can basically do a lot for the different departments. And I also think that use case, I mean, even though that it's maybe not the latest and greatest, because like everyone is talking about agentic now, but in the end, I think it's still absolutely a valid use case where the companies are just seeing a fast way to get started. And it also is not associated with a lot of risk, right? Because you always have a human in the loop, I would say. They're seeing what the output of the chatbot is. They can decide if it's good or if it's not good. And yeah, it's not a huge business risk if you're starting with that, right? If you're starting to, let's say, completely change your business processes with agentic AI or something like that, then way more risk is associated with that. It also has like the potential to give you more return on invest, but it's a risk thing. And I think for companies who are starting out, I think still internal chatbots, internal knowledge systems, that's a super good way to get started.
Yeah, yeah, I agree. I agree 100%. Um, I have one thought that I kind of agree with to an extent, um, and I think it comes actually from the CEO of IBM, where he said something along the lines of, so no citing anything, but he said, uh, actually at some point in time we might stop worrying about the models themselves, and the main point, actually, the main competitive advantage will be the system around the model. So your governance, your tools, everything that you kind of put, RAG among other things. What do you think? Is this something that you, because I feel like we might be reaching a plateau. I think you mentioned something along those lines previously, but we might actually be reaching a plateau for these models.
Yeah, yeah, I'm seeing it pretty similar. I would say. I think I know what statement you mean. I think he was talking also about like LLMs are becoming a commodity, right? And that the companies who are producing them do not really have like a competitive advantage. I would agree. Yeah. So we just see a lot of diminishing return now, and bigger, better, faster, and just more GPUs, more weights, and all of that. That's not the future. And like if one company is doing something, then the other companies are just like catching up so fast, right? It's not that you have like, let's say, your mixture of expert models, model architecture, and that architecture is yours and no one else is doing it. Like the competition is just catching up extremely fast. I think it's about the tools, the governance, like the how easy stuff is to just use, the economy behind it. Is it expensive? Is it not expensive? And then also, and I think almost every company, and that's basically maybe also the holy grail, is like, how can you infuse AI into your business processes and just automate a lot of stuff in there. I think it's not trivial because, I mean, at the end, like I just see it in the daily work that I do. Like you have people in the line of business and they're just like talking the line of business language. And it's so specific sometimes, and you do not understand what they mean because like, you know, all of the stuff about AI, you know, about the models, machine learning, whatever, but the line of business is talking in their language. And I think, I mean, that's a thing that IT has probably been trying to solve and is doing, right? I mean, it's not useless that we're doing that, but it's still, I mean, the problem is there to really translate the stuff from the line of business into your IT and how you're then automating stuff. And yeah, it's not just a model. It's way more stuff next to it.
And we kind of scraped the surface on that one. Because agents are a really, really hot topic. So maybe we just give it some time to discuss, you know, agentic AI on power, yes or no?
So I think the big yes for agentic AI on power would be the data sources. I mean, you have your SAPs, you have your Oracles running on the power server, really like mission critical stuff. So the big yes for it. The no, I mean, it's dependent on the use case, but you would really need to elaborate how much performance you actually need. Like, is it the GPU farm that we were referring to earlier? Like, how many agents do you want to deploy? Which model should be behind that? So that's then the question: is Spyre a good fit here or not? But yeah, that would be my simple answer.
Okay. Thank you, Henrik. Now I was looking at the comments while we were discussing, and I don't see any questions from the audience. So maybe we can go into, it's not real, you know, salesy type of stuff. But maybe I give you a couple of minutes to kind of plug the Spyre card, and you tell us, you know, where to start, who to contact, and all of the necessary info.
Okay, yeah, so the thing that IBM is not so good at, as you were referring to earlier, right? If you're running power systems today, then I think that the Spyre cards are just like a valid option for an AI accelerator, like bottom line. And I think it's good if even like the let's say CTO and so on is aware that IBM has a solution for that. So making that awareness is super important first. If you're saying, I want to see the Spyre cards in action, like what performance I'm getting, what this turnkey AI rack out of the box solution actually is, then feel free to contact Mirza, feel free to contact me. We can, for example, run a POC. I would love that. So we have a lab here in Eningen, and we are getting 8 Spyre cards. They are already installed in the lab. We can show you basically everything. And yeah, so I think that's a good way to get an idea of the technology, see what they can do, see how much performance you're getting out of the Spyre card, how the whole software stack is working. And yeah, either go through Mirza or contact me, and we then will do it probably together. Yeah.
Perfect. Yeah, I think that closes the topic. So I want to thank you one more time, Henrik. Thank you for being here. Thank you for taking the time to talk to us about Spyre. And we hope to talk to you very soon.
I hope so too. Yeah.
To our audience, thank you for being here, and see you next time.
Thank you, everyone. Thank you for being here. Bye bye.